Good day. I'm Mark Dela Cruz and this is my MEC 325 project about manufacturing wind turbine blades. First off, what is a wind turbine? Well, a wind turbine is a device that converts mechanical energy into electrical energy. And in today's video, we're here to talk about how the wind turbine blade is made. A wind turbine blade needs to be meticulously designed in order to maximize efficiency. So instead of just using a flat blade, a wind turbine blade needs to be curved on one side to create a low pressure pocket on top of it, like how an airplane creates lift. These also incorporate a twist in order to optimize how much of the blade cuts through the wind. After design is made, the mold is then cut from a block of material or foam using a CNC machine. The mold's thickness is calibrated, and then an epoxy sealer and paint is applied before a resin. The mold is then prepared for the layup by adding multiple layers of coating. After this, the mold is then transferred to a separate place in order to get ready for the layup. Now on to the main material. A wind turbine blade is made up of a mixture of a fiber, usually glass, and of a plastic resin, usually epoxy, which is then called a composite material. These are combined to make sure that there is a right balance of strength and lightweight. These materials are then stacked up on each other, making up several layers. The first layer is a peel ply added to the bottom. Then, a biaxial glass fiber is added. Then, two layers of unidirectional glass fibers are added on top of it. These are placed in the same direction. A second layer of biaxial glass fiber is then added. The top peel ply layer is then added. The next layers added are there to ensure that the liquid resin is absorbed well by the fibers. This includes a vacuum bag, which we'll talk more about later. Finally, an adhesive is added to connect it to the mold created earlier. Now going back to the mold. We want to prepare it for the wet layup or plastic resin later. So we'll add some additional layers and parts to increase the strength of the blades. These include adding spar caps and also some balsa wood. After this, the dry fiberglass layup is added and prepared for the resin infusion process. The most popular method used today is the vacuum-assisted resin transfer molding, or the VARTM for short. Whereas the name suggests, a vacuum is created in order to aid with the transfer of the resin into the fibers. Here, we can see how it's done in real life. Our vacuum was applied before the liquid resin was infused into the fibers. These are then cured at room temperature for around 2 to 8 hours. Adhesives are then applied in order to add some more structural support for the blades before the two halves are bonded together and cured for one last time. Finally, the two shells are then bonded together and post-curing is done in order to protect it from temperature changes. Final inspections are then performed and voila! We have our final product. Thank you all for listening, and I hope you learned something new. Bye!